Hey, this is Joe, and today let's talk about going from a standard form quadratic function to the graph of the function. And you know you have a quadratic in standard form when you have some value a times x squared plus some value b times x plus some constant c. And today we're going to talk about using this standard form and getting important points just from the values of a, b, and c, plotting those on an axis, and then graphing your function. And one immediate result we can always get when we're looking at our function is the value of a tells us whether or not our function is going to open up or down. And if you want more information about that, click on this card here. And one point that we get really quick for our function is finding the y-intercept of the function. Essentially all we do is we plug 0 in for x and we get some y value back, f of 0. Next, if you wanted to find the vertex of a quadratic in standard form, we'd get the x value would be negative b over 2a, and the y value would be f of negative b over 2a. And finally, we would use the quadratic formula to find our x-intercepts of our function. Now it's important to note that depending on what your quadratic function is, you may have 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. And you can check out the card here to find out how we determine whether our function is going to have 2, 1, or 0 x-intercepts. And in the two examples that I graph in this video, both quadratics are going to have 2 x-intercepts. So let's move on to an example. Let's graph f of x equals negative 1x squared plus 2x plus 3. And so what we want to do is take this quadratic function and find the y-intercept, the vertex, and the x-intercepts to give us an idea of what our quadratic is going to look like. Now, since our a value is negative here, we know that our quadratic is going to open down. Next, let's find our y-intercept. Quite simply, all we do is we plug 0 in for x within our function, and the value that we get back is going to be the y value of our y-intercept. So when we plug 0 in for x, we get negative 1 times 0 squared plus 2 times 0 plus 3. And since the negative 1 times 0 squared and 2 times 0 are going to both be 0, we're just left with 3. In other words, our y-intercept is going to be 0, 3. And one note you can make here is if your quadratic is in standard form, your y-intercept is going to be 0, comma your c value, whatever your constant is. And that is because every other term is multiplied by x, so when we plug 0 in for x, those are going to become 0. And so let's plot the point 0, 3 on our graph. Next, we want to find the vertex of our quadratic function. Since it is in standard form, we know that our vertex is going to be negative b over 2a, comma f of negative b over 2a. So negative b over 2a is going to be negative 2 over 2 times negative 1, which is going to equal 2 over 2, which gives us 1. That's the x value of our vertex. And to get the y value, we just take this x value we got, this 1, and we plug it into the function. And when we plug it into the function, we get negative 1 times 1 squared plus 2 times 1 plus 3. And that will end up giving us negative 1 plus 2 plus 3, which is going to equal 4. And so our vertex is going to be 1, comma 4, the x value being negative b over 2a, and the y value being the value we get when we plug 1 into the function. And so now we can plot our vertex, 1, comma 4, onto the graph. And finally, let's find our x-intercepts by using the quadratic formula to get the x values of our x-intercepts. And so all we do is we take the quadratic formula and we plug our a, b, and c values in. And as you can see, when we move on to the second step, we get negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times 3, all of that over 2 times negative 1, which then reduces to negative 2 plus or minus the square root of 16 over negative 2, which reduces to negative 2 plus or minus 4 all over negative 2. And so we're going to get two different values here. If we take the positive 4, we're going to get negative 2 plus 4, which is going to give us 2 over negative 2, which gives us negative 1. And when I take negative 2 minus 4, I'm going to get negative 6 over negative 2, which is actually going to give us positive 3. And so I get two x-intercepts here. I get negative 1, 0, and 3, 0. And we can plot those onto our graph. And now, since we already know that a is negative, so our graph opens down, and we have our vertex, we have our y-intercept, and we have our x-intercepts here, we can now fit our concave down parabola to the graph, as you can see here. And so one of the advantages of having a quadratic in standard form is that we can jump to the y-intercept, the vertex, and the x-intercepts by just using the a, b, and c values of your quadratic function. So let's work with another example. Say we want to graph the function f of x equals 4x squared plus 8x minus 5. My a value is positive, so that's going to tell us that our parabola is going to open upward, or it's concave up. And then once again, we can find these three sets of points. We can find the y-intercept by plugging 0 into our function, and when we plug that in, we get negative 5 back, so our y-intercept is going to be 0, negative 5, and we can plot that point on our graph. We find our vertex by finding the x value first, which is negative b over 2a, which in this case is negative 8 over 2 times 4, which is negative 8 over 8, which is equal to negative 1. We then find the y value by plugging negative 1 into the function, which gives us negative 9 as my y value. And so our vertex is going to be the point negative 1, negative 9, and we can graph this point. And finally, we use the quadratic formula to get our x-intercepts. And so when I first plug in my values, I get negative 8 plus or minus the square root of 8 squared minus 4 times negative 5, all of that over 2 times 4. That reduces to negative 8 plus or minus the square root of 144. The square root of 144 is 12, and so I'm going to have negative 8 plus or minus 12 over 8. And when I pick positive 12 and negative 12, I'm going to get 4 over 8 and negative 20 over 8 as my two values, which then reduces to 1/2 and negative 5/2, or 0.5 and negative 2.5, which then gives us the x-intercepts of 0.50 and negative 2.50, and we can plot those points. And since we know that our graph opens upward, and we have all these points here, we can fit our parabola to these points, and you see our function here. Now, this isn't the only way that you can graph a quadratic, but this is one way you can go about graphing a quadratic when you have it in standard form. I'm Joe, and thanks for spending some time with me.